So let's do a number of correlations, and then we will also do both the simple regression and the multiple regression. Okay, so the way to do this is that when you are doing correlation, you are essentially looking at two different columns, right? You're comparing two different variables and using the correlation coefficient to understand the relationships, the strength of the relationship between these two variables, revenue and in this case, advertising spend. The first thing you always want to do is you want to graph the data, okay? So the way to do that is you can just select all of this, both of your columns, go into insert, what happened here? I go to insert and scatter plot. And you do this to kind of make sure that there's somewhat of a linear-ish relationship. This isn't great, but it's sort of linear-ish, so we can kind of say, okay, it might be okay to run a correlation, right? And so we go here, we want to run the correlation, which is denoted by little r, and we use Excel's function, correl, or correlation, to do that. We look at our first set of values, array 1, which is right here, the values there. Then we hit comma to go to array 2, and we go and do the advertising spend here. Perfect. Once that equation is done, we hit enter. That gives us a correlation of 0.53. Correlation, little r, goes from -1 all the way to +1. At each of these ends, a correlation of -1 means that it's perfectly negatively correlated, and an R value or R correlation coefficient of 1 means that it's perfectly positively correlated. Since our value is 0.53, there is a positive correlation between ad spend and revenue. However, at 0.5, it is not really an extremely strong relationship. Ideally, we'd want it to be closer to 1. If we go into something like revenue versus website traffic, we can do the same thing again, right? Let's graph both the data. So go here, and we will graph the data into a scatter plot, and we see that, here, there's a bit more of a interesting relationship here, a bit more of a linear relationship. We want to make sure that there is a linear relationship in the scatter plot. If there is not a linear relationship, correlation coefficient will not give you the right, it's not useful to use the correlation coefficient if the relationship doesn't look linear. But in much the same way, there is linearity here. So let's calculate the correlation coefficient, which is denoted by little r, equals correl array 1, in this case revenue, select all of that, comma, go to website traffic, which is the other variable we're attempting to see how correlated it is to, hit enter, and now we have a value of 0.76, which is much closer to 1. So that means that there is since it's a positive number, there is a positive correlation, and because this R value is closer to 1, it's a strong positive correlation. So when we compare revenue and ad spends correlation to revenue and website traffic correlation, we see that based on the R values between this one and the R value this one, we can say that there is a far stronger positive correlation or far stronger positive association between revenue and website traffic compared to revenue and ad spend. So if we were to strategically deploy our resources, we would know that we have a better likelihood of increasing our revenues if we spent more money in getting more website traffic because there is a positive, strong correlation there.